This is Biddeford High School Graduation Standard A1.1, Solving Equations, Level 4 Notes. So, let's look at our learning targets. So you will be able to represent a real-life problem using an equation and solve. So that involves showing the equation based on the problem and solving the equation. So basically what this is saying is we are going to be dealing with word problems, so a sentence or a paragraph. And from that sentence or paragraph, we will have to put it into mathematical terms or create a mathematical statement, which we can also say is an equation. Okay? We'll also look at solving absolute value equations involving multiple steps. So this is not a big difference from level 3 of A1.1, where we solved one variable equations in one step. All we're doing now is we're adding the absolute value portion of this, which we will learn about that shortly. And the last thing we have here, we will determine when equations have no solution or infinitely many solutions. We haven't come across any examples that have had infinitely many solutions or no solutions, but on occasion we will come across these. Alright, let me get set up here. So let's deal with the word problems first. So we need to know what keywords we are looking for in a word problem. Okay, so these words, when we see them in a sentence or a paragraph, we know they go with the corresponding mathematical symbol. Okay, so when we list these words right here, in this column right here, we know that we will have to add. Okay, so let's start off with that one. Add sum increased by together more and plus and combined. Are these all the words that mean we have to use addition? No, but these are the most common ones that you will come across. Okay, let's go over to subtraction. Let's start off with subtract. Difference decreased by minus less than from and fewer. Okay, so whenever we see these words within a word problem, we know we either have to add or subtract a number or variable. Okay, at this point, if you need more time to write all this down, please pause the video. Great, now let's move on to multiplication and division. So for multiplication, we have product, which I'm sure you've heard of before, times the word multiple, and down here I've written down twice as well as triple. So we know twice is 2 times, triple is 3 times, and then if we were to go to 4 times, 5 times, we're just using the word times up here. Okay, so let's go over to division. We have quotient, shared. If someone or something is sharing something, it will be divided. Per, ratio, and last but not least, divided by. Okay, so whenever we see these words within a word problem, we know we either have to multiply or divide. And of course that depends on the word. So if we see the word product, we don't have to use division. Okay, we'll always use multiplication. That's just one example. Okay, pause the video if you need more time. So let's look at some examples here. So 3 less than x. So first I'm going to start off with my unknown. So I'll put x, that's my variable. Okay? So we have x and we have 3 less than. So less than means subtraction, and we have our number 3. So we're left with x minus 3. Okay? R increased by 7. So I'll write down my variable. Increased by, if we go back to our list, we see that's addition, and our number, which is 7. Next is the product of 9 and t. So the product of 9 and t is 9 multiplied by t. Next we have a number combined with 5 is 2. So we need to represent this number. We don't know what it is, so that means it's an unknown, so we'll use a variable. So for example, let's use r. No, let's use x. X combined means plus with 5 is, which also means equals, 2. Now again right here we have a number divided by 4. So I'll use n as my number, divided by 4. Okay? So looking at this, we have some sentences here, and we know we can build equations using these words. Once we have an equation, we can solve for our variable. Just like we've been doing. So let's look at this second to last example up here. We have a number combined with 5 is 2. So we said that's x plus 5 equals 2. So that's a level 1 problem right there. We know how to solve those. We'd subtract 5 on both sides. So we would be able to solve for this number. Pretty cool. So if the wording of a specific problem does not match the terms above, so we're reading through a word problem and we understand what the words mean, but we're not exactly sure what operation we should use, just use common sense. I find it's helpful to put myself within the word problem. Okay, so if I have a problem where someone's going to the grocery store or someone's going shopping, I try to pretend I'm that person and I try to come up with a reasonable answer. Okay, that might make more sense once we start doing some problems. So, pause if you need more time. Okay, so we're going to write an equation and solve these problems. Okay, so let's break it down. So we have a number. So let's use x because we don't know what it is. Subtracted by 16. Well, subtracted by means we have a subtraction sign. 16 will go down. Equals 4. So my equation is x minus 16 equals 4. Great, so there's 1/2 of it right there. So let's solve for our variable now. So solving for our variable, I make my t, add 16 over here, they cancel, add 16 over here, so I get x equals 20. Awesome. So let's move up to a harder one now. Okay, so for the second example, there are 100 cookies in the teacher's lounge. Mr. Flynn, Mrs. Deneen, Mr. Grover, Mr. Chaponis, and Mrs. Sanders are going to share the cookies equally. So we know equally means we have to divide. How many cookies does each math teacher get? Okay, so I have 100 total cookies divided by, again I can write that as a fraction. What am I dividing by? So let's see how many teachers I have. Mr. Flynn, Mrs. Deneen, Mr. Grover, Mr. Chaponis, and Mrs. Sanders. That's 5 teachers right there. And do we know how many cookies they get? No, we don't. So let's put a variable, let's say C. So there's 1/2 right there. So let's solve this. So I'll rewrite it. Okay, so I'm going to multiply by, actually we don't need to multiply at all. We can, what I was going to do, I was going to multiply by 5 on both sides. 5s would cancel. I would have 5c equals 100 and then solve for c that way, but we can just do 100 divided by 5. Okay, so what does c equal? C equals 20. And that is a lot of cookies. Okay, so let's look at this last one. This one can get a little confusing, but again, we got to break down every problem. We can't attack them all at once. So, Adam had to go to the grocery store to buy ice cream and bananas. He spent $12 on ice cream, but also wanted to buy some bananas. This was 10 less than double what he spent on bananas. How much did Adam spend on bananas? So, I'm going to underline in one color all the facts I know about the ice cream. Okay? So I know the ice cream cost $12. So I'm going to make an equation where I'll put an equal sign. On one side of the equation, I'm going to put my 12. because this 12 equals this entire expression right here. Okay, so I'll get a different color. So this was $10 less than. So $10 less means we have a minus 10. Double what he spent on bananas. So do we know what he spent on bananas? No, we have no idea. So let's put an X. What's happening to that X, our variable? Double. That means times 2. There. So on this side of the equation, I have all my banana information. And on this side of the equation, I have all my ice cream information. And at this point we have a level 2 problem, so we can just solve. So, we rewrite it over here. 2x minus 10 equals 12. Draw my t. Add 10 to both sides. So I'm left with 2x equals 22. So if I bring this up here, I have 2x equals 22. I can divide by 2 on both sides to get that x by itself. And I'm left with x equals 11. So again, these are tough problems, but we will get plenty of practice with these, don't worry. It's the level 4 for a reason. So if you need more time to write this down, please pause the video. Okay, so we're going to move on from word problems. Okay, we're going to talk about those unique situations that we talked about at the beginning of the video. So, what I'm going to do, I'm going to solve these two one variable equations right here. So I'll start with this one. So, distributive property, because I have parentheses, so I have 2 times p, which is 2p, 2 times negative 5, which is negative 10, equals, and on this side I have negative 10 plus 2p. So, make my t, let's say I want to add 10 on both sides. Okay, because that's what we're taught to do. Okay, so I added 10 on this side, so negative 10 plus 10 is 0. Now on this side I have the same thing, negative 10 plus 10, well that's also 0, so that'll also cancel. So I'm left with 2p equals 2p. Okay? That's a true statement right there, correct? So, what if I wanted to subtract 2p on both sides? Let's say I did that. So, minus 2p on this side, minus 2p on this side. So that cancels, so I'm left with 0 equals 0. So did I actually solve for my variable? We'll come back to that in a minute. Let's go over to this one. So I'll start with my distributive property. So on this side of the equation I have 10 plus 6k equals 6 times k plus 6 times 5. So again, as we've been trained to do, we subtract 6k on both sides, and same thing, our k's cancel. So what are we left with? Well, we're left with a 10 on this side equals 30 on this side. So if we solve for a variable, no. But there are two differences here. So let's go back to this first one. We have 0 equals 0. So think to yourself, is that true? Does 0 equal 0? Does that make sense? The answer should be yes. 0 is 0. Okay? These are the same. Now what about this over here? We have 10 equals 30. Well, last time I checked, 10 is not 30. So this right here is just not true. This is false. So we've got one true situation and one false situation. Okay? Pause the video if you need more time. So that's kind of weird. So did we do something wrong? Do we have to do these problems all over again? What's the deal? So I can answer that. No, we don't. This will happen on occasion. Okay, so when the equation is true, so that was our equation up here on the left, we say that our equation has infinitely many solutions. Okay, so what this means is no matter which number we plug into our variable, the equation will be true. Okay, so for that equation on the upper left right there, I could have plugged in, I don't know, let's say 1 for p, okay? And the left side would have equaled the right side. I also could have plugged in negative 100 for p, and the left side would have equaled the right side. So you can pick any number, let's say 4 million. You could plug that in for p on the left side and the right side, and you would still get the same answer. Great. So when the equation is false, so that was like our example up here on the right, we say this has no solutions. Okay, so this means that there's no real number we can plug in to make the equation true. Okay, so just to emphasize that, I'll write up here this one had infinitely many solutions. and this one over here had no solutions. Okay, so does our process change to try to solve for our variable? No, not at all. It's all just depends on our outcome. Okay, so let's go to absolute value down here. This is something new as well. So at this point, we have solved one variable equations using a single operation. We've also solved one variable equations using two different operations. And we've also solved multiple step equations. So the ones we had to play around with a lot to get the variable by itself. Okay, so now we're doing absolute value. So let's take a look at this example down here. Okay, so pause the video if you need more time to write. I'm going to continue on. Okay, so what are those bars? Are they different from the parentheses that we used in the, or with the distributive property? Are they? They sure are. Okay, those bars mean the variable n is an absolute value. Okay, so absolute value, let's define this a little bit. Refers to the distance a number or expression is from 0 on the number line. Okay, so again, I have my example down here. Pause if you need to write this down. Okay, so which two numbers are 6 units away from 0 on the number line? That's basically what our equation is telling us. So, I don't know, let's see. I'll draw a number line here. Okay, I'll put 0 right in the middle. So if I go 1, 2, 3, 4, 5, 6, we know that 6 is 6 units away from 0 on the number line. Okay? But we also have to go in this direction. So 1, 2, 3, 4, 5, 6. So on the negative side of the number line, we have -6. Okay? So both of these numbers, 6 and -6, are 6 units away from 0 on the number line. Okay? So what are my solutions, or how do I answer this? I say n equals 6, and n also equals -6. Okay? So let's go over how to solve these. That was a very simple one, but of course they're going to get a little more complicated. So to solve absolute value equations, we first need to get our absolute value expression by itself. Okay, so whatever is contained within those bars, we need to get that by itself. Okay, then we need to create two equations like we did above. Okay, so for this one right here, we created our two equations. We had n equals 6 and n equals -6. Okay, and by doing that, we could get rid of the bars. Okay, that doesn't make sense. We'll go to the examples in a couple minutes. So once we create our two equations, we can get rid of the bars and solve for the variable. Okay? Again, pause the video if you need to. Okay, so let's look at all of these. Let's start with this one up here. So, our steps tell us that we need to get this expression, the absolute value expression, or whatever is in between the bars, by itself. So, how can I do that? Make my t. I can add 3 on this side and add 3 on this side. So -3 plus 3 cancels out. So I'm left with the absolute value of 3 plus n equals 4. Okay, so my absolute value bars, or the absolute value expression, is by itself. Okay, so now I can create two new equations. Okay, so this expression is 4 units from 0. Okay, that's what we know currently. So I'll write 3 plus n equals 4. Okay, so just got rid of the bars. But I also need to put 3 plus n equals -4. Okay, so now I have two equations. Now I just solve for n in both. Okay, so let me switch up the color. I have 3 plus n equals 4. So I subtract 3, right? And I'll bring my answer right over here. I know that n equals 1. Okay, so that's one solution. So now I'll solve this one right here. Okay, so this top one I did down here, I'll just do the second one right here. Okay, so make my t, subtract 3 on this side, that cancels, subtract 3 on this side, and I'm left with n equals -7. So I have two solutions for this one absolute value problem. Okay, now let's move over to this one. So I want to get that expression in between the bars by itself. So make my t, divide by 7, divide by 7. 7 divided by 7 cancels. So I'm left with the absolute value of negative 3n equals 42 divided by 7, which is 6. So create my two new equations. So I have negative 3n equals 6. So I just got rid of the bars. But I also need to set it equal to negative 6. Okay, so now I'm going to solve. So again, this top one I'll bring right down here. So negative 3n equals 6. So I'm going to divide by negative 3. That'll cancel. And 6 divided by negative 3. So I'm left with n equals negative 2. Okay, so that's this top one. So this bottom one over here, I'll just do right over here. Okay, so divide by negative 3 on both sides. Negative 3's cancel. So I'm left with n equals positive 2. So those are my solutions. N equals negative 2 and n equals positive 2. So moving on to this third one, I'll multiply by 2 on both sides to get this expression by itself. So 2's cancel. So I'm left with k minus 3, the absolute value of it, equals 8. Okay, so I need to make two new equations. So I have k minus 3 equals 8. And I need the negative version of it. So k minus 3 equals negative 8. Okay, solve this top one down here. So k minus 3 equals 8. Make my t. I'll add 3 on this side. Add 3 on this side. So I get k equals 11. Okay, so that was this top one. This bottom one I'll just do right over here. So I add 3 on this side. That cancels. Add 3 on this side. So I get k equals negative 8 plus 3, which is negative 5. Awesome. One more. Then we get to do some practice. So right off the bat, I'll make my t. I'll add 2 on this side. That cancels. And add 2 on that side. So I'm left with the absolute value of n minus 8 equals 11 plus 2, which is 13. Okay, so from there, create my two new equations. Just get rid of the absolute value bars for the first one. And the second one, I need the negative version. So n minus 8 equals negative 13. Okay, this top one I'll do right down here. So I have n minus 8 equals 13. Make my t. Add 8 on this side. 8's cancel. Add 8 on this side. So I'm left with n equals 21. Okay, so that was this top one. Bottom one I'll do right over here. Okay, so I'll add 8 on this side. 8's cancel. Add 8 on this side. So I'm left with n equals negative 13 plus 8, which happens to be negative 5.